Yeah, I mean, we usually have that last day is usually we bring food, we play some games, just have some fun. But we'll see what this. I know as far as this semester holds, we're not planning to be back at all as far as the duration of the semester is. So I don't know when things will go back to normal. We know at least it's going to be through May that we're still kind of stuck in our homes in St. Louis, but yeah, I don't know how the wife would feel about that party at my place. Yeah, I don't think that'll be happening, knowing what's happening in Europe at the moment. Honeymoon in Greece. So, we're really coming up on the home stretch as far as this course is concerned. We just finished up 9.2 yesterday. We went through a few different examples with working with shared preferences. And shared preferences is a really good way to save some data to make it permanent, but only if you have a really small amount of data. So it's great for things like those preferences screens that we saw where you need to save just individual strings, integers, Boolean values. It's good for that, but it's not really good for storing even medium-sized amounts of data. So what we're going to look at next is using SQLite, and then using tomorrow and kind of for the last bit here of Unit 4, we're going to talk about something called Room that kind of hides some of the details of SQLite. Makes it work a little bit more like kind of NAD framework worked with the SQL Server database. So that's what we're getting into today. We're going to look at the SQLite and just kind of get an intro primer to that. This doesn't really dive too deeply into the code. Mostly it's just going to be talking about SQL and how SQLite is maybe a little bit different than, say, MySQL or SQL Server. But I do want to try and do a code example today. So we'll probably go through, the plan is to go through these slides, and then we'll take a brief break, probably a 20-minute break, and then come back and try to do an actual example with SQLite before we go on to Room tomorrow. Just so you have some intro to what kind of things look like or used to look like when we were working directly with the SQLite database classes themselves. Because there will be a few things that leak. There will be a few things that you have to know. The kind of abstraction that we use with Room is not fully, doesn't encapsulate all the details of the database away, but it does do a good job of encapsulating a lot of them. So that's where we're at today. We want to talk about how do we use the SQLite database to store data locally on the device. One downside of storing it in the SQLite database, same thing with anytime you're storing files on the device, is these are files that you can't really share between users, right? So if you're trying to build some sort of social media platform, whether it be for event planning or any sort of other social media kind of thing, looking up reviews, articles, this is not going to be your best bet because you're not going to be able to use SQLite to really have, okay, my reviews I entered in my books or the restaurant, I can now share those with some other user on the internet. I can't really do that with SQLite. So that's where things like Volley come in, and web APIs and dealing with Firebase and things like that, where you can actually have that data out on the internet and shared between different users. But this is a good way to kind of store data on the device if you want it to be maybe private to that specific user, or you need to do what we would call caching and save it kind of temporarily for offline access. Okay, so SQLite's really good for having this data stored for offline access. It's not very good about sharing this data from one user to another. Okay, So that's kind of the limitations and boundaries to keep in mind as we're working through this. So we're going to talk about we're going through 10.0 today. We're going to talk about the SQLite database, and then there's slides will cover a little bit about queries. And then we'll also talk a little bit about some of the quirks with the SQLite database itself. Because there's a few things that I would like that you really do need to know as you're working through it. Some kind of underlying details of how SQLite works and how it's different than, say, SQL Server. So this is really what's in here is primarily a refresher. This really assumes that you already know relational databases, that you know a little bit about SQL databases in particular, and you know a little bit about the SQL query language. We did cover SQL last semester. We talked about this. We use SQL for all of our websites that we created last semester, so hopefully you have some recollection of what we did there and how we did things to kind of get you a jump start. But we're going to try and refresh, go over some of the things that, because it's been a while since we touched SQL. Okay. So let's start talking about the SQLite database. Okay. So in SQL terms, or relational database terms, we talk about a relational database stores all of our data stored in tables, which have rows and columns. And if you remember right from last semester, they kind of function like a spreadsheet, right? So you've got rows of data, and then the columns determine what the name of that data is, as well as what data type it is. Okay. A field then is an intersection between a row and a column. That's a place to put an individual value. So that field will either contain a single piece of data, or it will contain a reference to another row in a form of a foreign key. Every row does have to have a unique ID. We call that the primary key, and we use that to identify that row within the table. Your column names also must be unique, so I can't have two name columns in the same table. I can have a name column in my, say, orders table and a name column in my parts table, but I can't have two name columns in the same table. They have to be different names. Okay. So here's maybe an example table. We call this this is going to be our word list table. You can see the name of the table up top, and it's got 3 columns. So we have the ID column, which is storing an integer. That's our primary key. And then we have the word and the definition. So both the word and the definition are storing textual data. Okay. So we can see the first row has an ID of 1, word alpha, first letter. Do keep a copy of this slide. I'm going to go ahead and put this in Discord because this particular data, this small table is what we're going to do all of our examples off in the slides. So you'll definitely want to refer back to this data as we go through. Okay. So that's kind of how the data is arranged in a typical SQL database. It really applies to any sort of SQL database. MySQL stores their data this way. Postgres stores their data this way. SQL Server stores their data this way. Oracle stores their data this way. So, and as long as you're using a relational database, this is the normal structure. It kind of looks like a spreadsheet. Okay. So the SQLite database, the SQLite library, is a little bit different than other database engines in a number of ways. So first of all, it's really self-contained. To use the SQLite library, you don't need any other secondary libraries. And in fact, if I follow the links here, it'll kind of talk about what that means. So from the SQLite perspective, it really doesn't, the library does not depend on any other libraries, and it only depends on a very small number of standard methods that are in most operating systems. And these are basically part of the C library because SQLite is well written on C. So it's a very small library. The entire, as they say in here, the entire SQLite library is just one code file. It's just one C code file. That's it. So that means it's very simplistic, very lightweight. It's pretty flexible, as you might say, but it also means that you don't get a lot of features that you might see in a more fully fledged database, because it's only meant to be kind of very lightweight. So there's a lot of things that you might be familiar with in a full scale relational database that you won't find in SQLite, and we'll go through some of those things. So it's self-contained, doesn't need a lot of dependencies. That's one of the reasons that it's available on Android, because it doesn't need anything else. Because it's just this one C file, it's very easy to adapt it to systems and platforms that don't have a lot of resources. So whether that be all the way down to maybe on our Arduino device or a Raspberry Pi, it's very easy to run a SQLite database on those. But it also means that you can build it into any sort of application, whether it be a C# desktop application, a C# website. You can actually build it into basically anything at this point. So it is self-contained, doesn't need anything else. The other big thing is that it's what we call serverless, and it's what we refer to kind of classic serverless, which means that you don't have a database server. It doesn't have to go out to the internet to go fetch your data. Your database is actually running inside of your own app. So it's kind of like, rather than, when we set things up last semester, we had to set up SQL Server, and then that had to be running on your machine so we could talk to it. It also meant that there was some administrative overhead for like setting up databases, granting permissions to that database. That doesn't exist, right? So with SQLite, it just runs as part of your app. It runs in your application space. It doesn't connect to any sort of server on the internet. Also, doesn't require any sort of configuration. You set it up, it goes. There's no permissions, no anything like that you have to set up to make it work. It's also entirely transactional, and we'll talk about that in the next few slides. But transactional means that everything we do either happens or doesn't happen at all. Okay, so if we tell SQLite to go insert a row, delete a row, update a row, either the entire change that we tell it to do happens or nothing happens at all. That's what we mean by transactional. Okay. So what is a transaction? Because this is kind of a common database term. So a transaction is any sort of is a sequence of operations that we want to be performed as a single kind of logical unit. We want to say read some data, update some data, or read some data, insert some data, all those kind of things. We can group that into a transaction and say, okay, before I do anything, we start the transaction, begin the transaction, do our things, and then we either commit the transaction, which says, okay, I'm done with these things, go make it all happen, and go save it, make it final. Or we get to the end and or somewhere in the middle and we say, oh, things aren't right, I don't want to actually do this, and you roll back that transaction. So you roll back that transaction and nothing actually happened. So that's important. It does support transactions, and a transaction is an all or nothing thing. Either everything in the transaction happens or nothing in the transaction happens. Now, this logical unit of work, we kind of, when we're talking about transactions, there's an acronym that goes by the name of ACID. We say that their transactions are ACID, and which is an acronym here for atomicity, consistency, isolation, and durability. That's what those 4 letters stand by. So what does that mean? So let me come back to that. So it's all or nothing. So that does mean things in terms of the transaction. So if the program crashes in the middle of your transaction, those changes aren't saved. Those changes just go away. You don't get part of those changes you don't get part of those changes. The changes that were partially done will be undone when your program boots back up. Same thing if you have an operating system crash or some sort of power failure where you lose battery life. And that's important. These things of undoing a previous transaction don't happen if you're working directly with the files. If I'm directly writing to a raw file, I don't get this guarantee. I don't get this guarantee if I'm writing files, whether it be JSON or text or binary files. If I'm writing the file, I don't get this guarantee. SQLite gives me this guarantee with kind of a way to roll back changes when it boots back up. Okay, so let's talk about ACID. So ACID, we got these 4 different letters that kind of mean different pieces. So atomicity means, so our transaction must be atomic. And that means that that's the idea that either all of the things happen or none of the things happen. It's atomic. We mean that in the sense that atomics kind of are the smallest building block. So we can't subdivide our transactions into smaller units. They have to be all. This is an entire operation. You can't subdivide it. That's kind of the point. You can't say, I'm going to do some of your work, but not all of your work. Okay, either everything has to happen or nothing has to happen. Consistency is also important. The other part, that's another part of transactions. We want them to leave the data in a consistent state. So that means things like potentially wanting foreign keys to be still reflected when we're done. We don't want to say, okay, well, I've got this row here that refers to user ID 5, but there's no user ID 5, right? So that would be an inconsistent state if there's a foreign key that doesn't actually refer to another row that exists. There can be other cases of consistency. So for instance, let's say we have a number that takes up 32 bits. Well, we don't want to write 16 of those bits and then leave the other 16 what they were originally. Similarly, with a 64-bit number, we don't want to say, well, we wrote the first 32 bits, but the second 32 bits failed to get written because we lost power in the middle. So now you have garbage in there because you have half of the new value but not the other half of the new value. That's a problem, right? So we want consistency in the data. So that means all of our constraints are upheld, whether it be foreign key constraints, unique constraints, any other sort of constraints that we might put onto the schema. All of those things need to be upheld when we finish the transaction. Okay, so none of those constraints should be violated. Okay. It's also important that transactions are isolated. So for instance, let's say you've got 2 parts of your code that are both trying to interact with the database at the same time. You don't want those to kind of fight against each other, where one transaction gets part of its operation done, but not the whole thing, and the other one gets part of its operation done, but not the whole thing, just depending on how they interact. So the way that the transactions must be run or executed must be in such a way that there is no interaction between those 2 transactions that are happening at the same time. And oftentimes what that means is if 2 parts of your code are trying to write to the same table, they have to wait for each other. So let's say you have 2 different services, 2 different job services. They both end up running at the same time, and they both end up writing to your posts table. or your articles table at the same time. Well, they need to, one gets to go first, it gets to do its thing, it either entirely happens or doesn't, and then the next service gets to save and modify the database, and that either entirely goes in or doesn't. So that's an important thing. That idea of isolation, again, that's something that you don't get if you're just directly writing files. Okay. Then the fourth piece of that is that our transactions must be durable. So once I commit them, they have to stay. Okay. Once I've successfully committed a transaction or successfully run an update statement, run a delete, run an insert statement, if SQLite tells me that it finished that successfully, it must be on disk. It must not be lost. Okay, so if SQLite were to come back and say, okay, I've saved your data, and then right after it did that, the device loses battery power, shuts off, if that data is lost, then it's not durable. Okay, so it's got to be able to, once the database tells me that it's been successfully written, it must then be able to survive a crash of any sort or a power loss. It must be physically on the device. Okay, so all of those things, the atomicity, consistency, isolation, durability, all of those four pieces are things that we don't get if we're just writing to raw files, which is part of the motivation for using a database here over using just say, well, let's just write this JSON to a file, or let's just say we'll write this out to a text file. Those are things that we don't get. So it can mean that, well, weird things happen on devices. They lose. It's not unusual for a device to lose power. You've got a device that's running on battery, and depending on what's going on, it may be running through that battery pretty quick. So you just kind of got to keep that in mind. But this SQLite will deal with those four pieces for us, rather than us having to deal with all those problems by directly writing files. So because of all that, we don't usually recommend writing files directly. Unless it's really, really important, unless you really, really have a good reason for it. It's usually better to put it in a database rather than sticking it in a file. So SQL, there's a few basic operations in SQL, just to refresh. You've got your insert statements to insert rows. You've got your update statements, which allow you to modify the data or update rows in the database. You've got your delete statements, which will delete rows of data. And then you've got select statements, which is what we'll use to retrieve rows that meet a particular criteria. That's how we run all our queries, is through select statements. Okay. So before I get into queries and a refresher of how that works, are there any questions at this point? Okay. So let's talk about writing queries. So a specific example of maybe what a query might look like. Again, this is going back to the data that we looked at back on slide 7. As I say, let's write a select query to go get a word, go get an item, go get a row from the word list table. So I'm going to start it with select word description. So I'm saying I want the word column and the description column from the word list table where the word is alpha. So if I ran this, I would get 2 rows back. I would get that first row, which is ID 1, alpha, first letter. And I would get, let me just bring this over. So I would get this row back, 1 alpha, first letter. And I would also get this row back, 3 alpha, particle. Because both of those have a name of alpha. Okay. So the kind of generic syntax for the select statement starts with the word select, and then I list the columns that I want back, and I say from what table. So there I was saying I wanted from the word list table. And then finally I'm going to say where this column has this value. Okay, so that's the basic generic structure of a select statement. It's always going to have select, from, and typically where. Where is actually optional. If you want all the data, you don't have to include a where clause, but typically you don't want all the data, so you're usually going to have one. Okay, so let's look at the first part of that. So that it starts with select, and then I'm going to specify the columns. If I want to specify specific columns, those are going to be separated by commas. If I want all of the columns, then I'm going to put a star there. So the star is going to retrieve all the columns in that table in the order that they are in the actual database. Whatever order was defined in the schema, that's the order that they're going to come back in. Okay. If I specify the column names explicitly, say word comma definition, then the first column I get back will be word, the second column will be definition. If I were to reorder them a different way, say definition column word, then the first column I get back would be definition, the second column would be word. That's important when we're dealing with this in code, because the order that those columns are specified in, we actually use those numbers in code to refer to the column. So if those change, that can cause an error and an issue with your code, where you end up pulling back the wrong columns because their order has changed. So typically with SQLite, I would not recommend using that star, hardly ever, because if your schema changes, then you're going to have all sorts of problems. So it's usually better to always list the columns that you want. So I would even, rather than using star, I would say underscore ID / word / definition. I would list all of the columns. That way, if things change, if the columns were to change and be in a different order, it doesn't break my code, because that can happen. The second part, the from table, that's just where we specify what table we want the data to come from. So if we have more than one table, we need to specify whether or not we have more than one table, we need to specify the table name there. Okay. So the third part is that where clause. Okay. So that where is the keyword that clause starts with. So it's always going to start with keyword where, and then we're going to specify what are the conditions for the data that we're interested in. So it's the simplest kind of example is column is equal to some value, right? So I might say, well, I want the row with ID 2. So I would say underscore ID equals 2. And that would give me the row with ID 2. There's also a few other operators besides equal that we can use. So we can use equals. We can also use not equals. There's also an is and an is not. For the most part, equals and not equals are almost the same as is and is not. The difference with equals and not equals, if either side of the comparison is null, equals or not equals always evaluates to false. Either side, both sides, if either one of those is null, you get false. On the other hand, is and is not work correctly as you would expect them with null. So with is and is not, if I say this value, I say the name is null, then that would evaluate to true for any case where the name is actually null. Same thing with is not. Both of those things work correctly with nulls, at least the way you would expect n equals to work in, whether it be C# or Java or JavaScript. It's the way you would expect equals to work. It's basically how is and is not work. Like can also be used to do kind of partial matches. So I can say I want it to kind of match this pattern. I want this to maybe be, I want to search within a value, maybe for a substring, to say, hey, this word contains this, the name contains names an A, or the definition contains letter. So I can use the like for that. There's also less than, greater than, less than or equal to, greater than or equal to, and there's a special keyword called between. So between is used to kind of shorthand ranges. So it will let you do things like, I want this value be between 5 and 7, or I want this date to be between April 1st and April 23rd. I can do that with the between. There's also the collate operator, and that will change what character set is used to compare string values. So you may want to set that if you're comparing two strings to say if they're equal. That's how you specify should it be case insensitive or not case insensitive. That's the big thing with collate, is you're saying, do I care about the cases matching, or do I not care about the cases matching? That's how you make that comparison work. You can read more about this at the link below, SQLite.org, lang.expression. There's quite a bit there about how those different pieces work, as well as some other things that are relevant there. For instance, if you want to concatenate two strings, that's a double pipe. It kind of looks like an OR. But anyway, moving on with the rest of this, with select statements, we can also use the keywords and an OR. Those are logical OR, so that's logical operator. So we can say, well, this condition has to be true and this one, or we can say this one has to be true or that one. And we can also use parentheses in there too to change the precedence of how those ands and ors operate. So that's an important thing to keep in mind too. If you start mixing ands and ors, you'll definitely want to introduce some parentheses to control when they happen. Okay. So and lets us put two different clauses together in our where clause, and we can do as many ands as we want. We can do as many ors as we want. Order by then says I want to sort the results in this specific order. So here we're saying we want to order it by word descending. So that's going to order it by the kind of alphabetically descending. So from Z to A. If I say word ASC, word ascending, then it would sort it from A to Z. Descending would be Z to A. Okay, so ASC or DESC for descending. The final clause that we can add in there is what's called the limit clause. Okay, so limit clause says I don't want all of the results. I only want the first X results. So here I'm saying I only want the first result. Limit 1 says I only want the first result. If I said limit 10, well, I would only be getting the first 10 results. So I can specify that I only want some of the results, which allows me to do things like paging or other things where I'm on, for instance here, this limit, I'm probably expecting to just get one result back. I only care about that first result. So if we kind of look at what this query is doing, we're saying select ID from word list where the word is alpha. Okay, so that includes two results right now. It could be the first row, it could be the third row, because both of those have the word alpha. And then we say, and the definition is like %art%. So a percent says any percent in a like says any number of characters from 0 from 0 characters there to an arbitrarily large number of characters can be before art, and then I'm also having a percent at the end, so any number of characters can be there. So any number of characters followed by art followed by any number of characters. Well, that basically means that art can be anywhere in the word. Okay, so if we look at the data, we know that we're only returning this first row and that third row because those are the only ones that have a word of alpha. But I've said also, and I only want the ones that have a description that contains art. Okay, so if I look at this first one does not contain art, but this second one does. Starting at the second character, we've got art there. Okay, so the only result that we'll get back is that third result. And given that we've said we only want the ID, the only thing that we'll get back from here is the number 3. So this will return the number 3. That's it. Okay, so look at some more examples of different queries that we could write. Let's say we want all of the data for the word list table. So I could say select star from word list table. That would give me all of the data. If I say, well, let's grab part of the data. So I'm going to say select word definition. So I'm only going to get these 2 columns from the word list table, and I'm going to say I only want the rows where the ID is equal to or greater than 2. Right? So that wouldn't include the first row because it's ID 1, but it would include the second one because it's 2, and we say greater than or equal to, not strictly greater than. So that would give us a result back like this. Beta, second letter, would be our first row that we get back, and then the second row that we get back would be alpha particle. Okay, so you'll notice that there's no IDs on there, and you'll notice that the first row is missing. Okay, another example here was the one we just looked at. I could say select ID from word list table, so I'm only going to get the ID back, and I'm only going to get the ones that one row that matches these criteria. So I'd get it back as just a single, I would get it back as a kind of a list basically, but it would only have one row in it, and that one row would contain just the number 3. Here I'm saying, well, I want all the data, so select star from the word list table. We're then going to sort it backwards, because we say descending, by the word. Okay, so that means that beta is actually going to be the first entry in the list. So it would be row 2, which is beta, and then it would be either of the other 2 rows from there. And then we're saying, well, I only want the first result. So we sort it by the word descending, and then we get the first result. So we're going to say that only brings back that beta row, the second row. Okay. And then finally, another example here we have, we'll say select star from word list, limit to 1. Here we're doing something a little bit different with that list clause. If we just look at that limit clause, but if we just look at the first part, we're saying, oh, well, let's return all of the data from the word list table. Okay. Now the limit, if I have 2 numbers here, what this says is return the first row. I'm going to return the first item starting at position 2. So this first 2 here says which row number am I going to start at. Okay, so I'm going to start at row 2, and then I'm going to use the second number to determine how many rows I get back. So I'm going to go to the second row, and then I'm going to just return that first row. Now, one thing to note here with this counting, it doesn't start at 0. The first row is 1. And this 2 doesn't represent the ID 2, right? So if the IDs in the table were maybe 3, 5, 7, this would still return the second row. It's not saying ID 2. It's saying the second row. Okay, that's kind of a common misconception. It's not an ID. It's the second row. So this is how you would do paging. If you needed to page the results, you'd say, okay, I want to page the results into 5 items per page, and I want to say, well, 10, and I want to get the third page. So if I want to get third page, 5 items per page, this would be limit 15, 5. Second number is basically your page size. The first number is how many items are you going to skip over. So we're going to skip over the first 15, and then, oh no, the third, no, it'd be 16. Would be, no, it would be 15. Would be 15. So it'd be 15, and then 1. Is that right? 15? Yeah, something like that. Okay. So how does this kind of work with running these queries against SQLite with Java? So what we've looked at so far has been how to write the SQL statements for the select clauses, and that's kind of a refresher. So what we want to look at next is a little bit of the Java code that we need to write to run these SQL statements. Okay. So if I'm working with the SQL database directly, I can use the raw query method to run just a piece of SQL, just a SQL select statement. So here I would say, let's create a string variable to store my query. So my query is select star from word list table. So I have this stored as a string. And then I'm going to say db.rawQuery. We're going to give it the query, and a null is the second argument. That's going to give us back something called cursor. Cursor is how we're going to retrieve the data and look at it, and we'll look at that and we'll talk about that on I think 2 slides from now, and we'll kind of look at that. But I'm going to look at that. I'm going to use that cursor to actually retrieve the data. So raw query is what I use to run just straight up a raw SQL query. Raw query is not the thing you want to use if you want to say do an insert or an update or delete. You actually need to use a different method for those, and basically they're just called insert, update, and delete. So raw query just runs select statements. Okay. That second parameter, let's talk a bit about what that is. So the first parameter is a SQL statement. That second parameter allows us to insert arguments into that statement. Okay. So if there's parts of the statement that change based on user input, we want to pass those through as that second argument. Okay, rather than concatenating them into the string, which can lead to a lot of different security problems, we want to allow the system to do the replacement for us. So rather than concatenating in the 2 here, which would potentially leave us open to a wide range of SQL injection attacks, we're going to just put a question mark here. So I'm going to say select word definition from word list where the ID is question mark. So that question mark will be replaced with our first argument. So our first argument is 2. So we got this string array of arguments. It only has 1 right here. If I had a second argument, that would get put into the second question mark. So basically this ID is going to get replaced with 2. But it's going to get done in a secure manner. Okay, so I pass the arguments to the second parameter, and that does that. Okay, I can also, in addition to the raw query method, which allows me to just write out all of the SQL myself, there's also a query method, which is a little bit more structured, quite a bit more limiting in terms of how it kind of works together. It's intended for kind of better security is the idea, why it's there, as well as maybe at least attempting to try to simplify the code. It doesn't always necessarily make the code more readable in my experience, but it can help sometimes. So basically, here's the query that we're trying to write. We're trying to write select star from word list table where the word is alpha, order it by word ascending, limit is to 1. So that would give us back this result. Okay, we have us back alpha particle, because that, if we look at kind of how the query is running, okay, so we want the 2 rows that have alpha as the word, so that gives us the first row or the third row. And then we're going to order them by the word ascending. Actually, that probably should be probably by the ID ascending. Because they both have the same word. And then we're saying we want the second row with a limit we want to go to the second result and just pick that one. So we've got all these different clauses over here that we want to try and build up. Okay. So what we're going to end up calling is the DB query method. The DB query takes kind of a long list of arguments. So that first argument is the table, the name of the table, and then the columns you want, the where clause you want to use, any arguments that you want to insert into that where clause, a group by clause if you have one, a having clause if you have that one as well. Having kind of goes with group by, order by clause, and your limit kind of criteria, your limit clause. So the way that we build these out, if we want to specify the table, so the table is just a string. We just apply the name of the table. The columns has to be a string array. So here we're saying we want all the columns. We want to specify a star, so I'm going to pass in a star as that. If I wanted to say I want ID, word, definition, I would supply an array with those 3 column names in it. Next we have the where clause, so it's just this part of the where clause. I don't actually include the word where in the where clause. I'm just going to say word is equal to question mark. And it's going to automatically go ahead and replace the argument there. And then I've got where args, so alpha is what I'm going to put in as the argument. I've got no group by or having, so I'm going to set those to null. And then my order by would be where word ascending, and then finally I would have limit to 1. And those should actually have semicolons at the end of them. I'm not sure why they don't, why those lines don't. So we take all that together, all those variables, and then pass them in. Usually we won't write out the query this way. Usually we just take a lot of these parameters and just pass them in directly as literal values to this query statement. So I would, rather than having this separate here, I would just say query word list table, have my list of columns here, have my where clause. Most of these things I would define in line as I'm calling it, rather than saving them to variables before passing them in. So this looks like a lot of code, but in reality, when we usually write it, we usually write all of this in really one line. And this is just to try and kind of see what the name of those variables are. What do they do? Okay. So whether I run call the raw query method or I call the query method, both of those things return what's called a cursor object. Now, cursor object in Java is what you use to access rows of a database. Okay, and you kind of think of it as a pointer to the current table row. It's how you kind of read and write your result set. Typically, we'll just do read with it. We'll say, okay, I've got the data. Let me read the next row, get all the values out of it, read the next row, get all the values out of it, read the next row, and then get all the values out of it. So typically when you're using a cursor, you'll have one of two cases. You'll either be expecting multiple rows back, in which case you'll have some sort of while loop. But if you're only expecting one row back, then you'll deal with that as just a single if statement. So let's go through some quick examples of what that might look like with the cursor and how to read the cursor. So let's say I'm doing select star from word list table. Okay, so that's my query. I'm going to call db.rawQuery, pass in that string query that I have, no parameters because I've got no question marks, and then I'm going to save that cursor. Okay. Now here I'm using that try with resources syntax because I need to make sure that that cursor gets closed. Okay. If that cursor doesn't get closed, you're going to run into memory leaks with your application. It will eventually crash over time because it won't anymore be able to access the SQLite database if you don't close those cursors. So you really, really have to make sure that you do close those cursors. Kind of like you need to make sure you close streams, but even more so with cursors. So once I've got the cursor opened and started, I'm going to write a while loop. I'm going to say cursor.move to next. Okay, move to next takes it to the next row. If there is a next row, it returns true. If there is not a next row, then it returns false. So calling move to next will give us each of those rows in turn. Okay. So if I grab the first row, I can then say, well, I want the ID. So I'm going to say cursor.getInt. When I call getInt, I need to tell it the index of the column. So we know from the table that ID is the first column, so it's index 0. So this will give me the first column as an integer, which will be the ID. The next column we know is index 1, and we'll get that as a string. Okay, that's the word. And then the last column we know is also a string, and that's the definition. So that's how the code might look to start to read the data out. Obviously, I'd probably want to load this data into some sort of list and then return it. So that, as we go through a more complete example, you might see that is usually we'll add these results to a list and then return that list. If, on the other hand, I say I only want to retrieve a single row, maybe I only want to retrieve the row with ID 2, it might look like this. So I'd say, okay, let's save the query again. Let's save it to a string. But here you'll notice I've specified that I only want the word and definition columns, whereas here I used a star. And here I also have a where clause. So I'm going to say I only want the word and definition clauses, and I only want the row with ID 2. Okay. So I'm going to call db raw query, pass in the query, pass in the args. Again, this try with resources is to make sure that it gets closed. Make sure the cursor gets closed when I'm done. And then I'm going to call cursor.move to first. So this is going to return true if there is a result and false if there is no result. Okay. So I can look at the first result then, assuming there is one, and I'm going to say, well, let me get the word, which is the first index, word 0. Second index is going to be the definition. Now notice how that works. So here index 0 is the word and index 1 is the definition, versus when I ran this query, index 0 was the ID and index 1 was the word. Okay, see how that's different? It changes based on the columns that you select. Okay. So here I'm asking for all of the columns, so it's 0, 1, 2. Here I'm asking just for the word or definition column, so it's not returning an ID column. So those indexes, like 0 and 1, are the index of it in the result set, not the index of the column in the table. Okay. Any questions with this, with the Java side of this? Okay, so that's kind of the core part of how we write code in Java to run queries. We'll go over a little bit more when we do a live example in a bit, but that's kind of the fundamentals. Next up, I want to talk a little bit about some of the quirks of SQLite. So this is something that wasn't originally on the slides. This is something I had to pull and retrieve and add to the slide because it's really a few things that you need to know. So these are on the updated slides. They were not on the original slides if you looked at them beforehand. So SQLite, this is kind of pulled from their own documentation. The SQL language is a quote-unquote standard, big emphasis on the air quotes there. Even so, it's considered kind of a standard, but even so, two different SQL database engines never work exactly the same. So if I were to write a SQL statement, even a select statement for SQL Server, there's a very good chance that I might have to change that select statement going from SQL Server to MySQL to Oracle to SQLite. All of the different versions of SQL have their own little nuances and in little ways that they are implemented that's different. So they all have their own little peculiarities, oddities. This isn't really an exception to the rule. So there's a lot of things you want to know about SQL. So I'm going to bring up this quirks page, and this is going to cover quite a few of these different points. So first of all, we did mention this earlier, SQLite is embedded, it's not client server. So normally when you're working with a SQL database or any database, you usually have your application as kind of one process, and then you have to do some sort of network or process communication to connect to your database server. Okay, so that's usually running as a separate application. But with SQLite, it's literally embedded into your own application. If SQL crashes, if SQLite crashes, your entire app crashes. So you don't want that to happen. Typically, SQLite's pretty stable. It probably won't crash, but if it were, you're going down with it because it's part of you. It also means if your app crashes, SQLite also crashes because you're all going down together. So that's one thing you need to keep in mind. It also means that there's no like connection string or anything like that you need to connect to your database. So on that note, if you're looking for where your database files are stored, your database files are stored inside of your internal storage. So similar to how our shared preferences are stored in the internal storage folder for our application, same thing happens with SQLite. It's stored in the internal storage folder. Also, a very important thing to know about SQLite, it is very flexibly typed. Okay, the data types are not very strict at all. So you can, for instance, say that I want this column to contain an integer, and you can put the string ABC, XYZ in there. That's all okay. SQLite will let you do that. It will not enforce the data types on your columns. Okay. It also doesn't have any sort of character limits on the text columns. So you can say, I want this column to be varchar 20, but it will not prevent a 100 character string from going into that varchar 20. Yes, to answer your question, Graham, there is a way to look at the database tables, similar to how SQL Server had kind of a management studio. The tool that I generally use is something called SQLite Express. There are a few different tools out there that can look at it. There's 2 or 3 of them. SQLite Express is the one that I usually use, and I'll kind of show you how to operate that. Okay. So things are very flexibly typed. That's an important thing to pay attention to. If you tell it to store it as if you accidentally put a string into your integer column, you will end up with a string in your integer column. If you put an integer into your string, you'll have an integer in that column. It won't prevent you from putting the wrong data type into that field. Talking about data types, there's also in SQLite, there is no Boolean data type, and there's also no date-time data type. So if you want to store Booleans, you'll want to use an integer column instead, and use 1 as true, 0 is false. You do not use a Boolean column. There is no such thing really as a Boolean column in SQLite, or a bit as we called it in when we were working with SQL Server last semester. So Booleans are actually stored in integer columns is the way we want to do that. And we specify the data type of that actually as integer. Similar thing kind of goes for a date time. There really is no date time data type in SQLite. There are some methods that can work with dates and times, which is kind of counterintuitive. But basically the way that SQLite works is sometimes it'll deal with the dates as strings, and sometimes it'll deal with the strings as integers, as in number of seconds since 1970. Now that's interesting because it's seconds since 1970, not milliseconds. It can also deal with dates potentially as real numbers. And real numbers is kind of measuring how much, measuring relative to another standpoint for the Julian calendar, which is not since 1970. So that one's actually a very weird kind of one. So just be forewarned. Yes, there are some methods and some functions in SQLite that can deal with dates and times. You can use them in some cases, but you're probably better off, if you can, doing your math with dates and times in Java rather than trying to do them in SQL. Should you be able to. Okay. Now there are cases where you may want to use that, but you just have to be very, very cautious. In what it means really when we're storing dates and times, we'll either store them as a string or a text data type, or we'll store them as an integer data type. We generally don't store them as a date or time or date time column. Okay. Next part. Foreign key enforcement is off by default. So normally you would expect your enforcement for foreign keys to be turned on. That's not necessarily enforced automatically. That's something that kind of just be wary of. It won't necessarily prevent your foreign keys from getting out of sync unless you've got it set up that way. Primary keys can sometimes contain nulls. That's entirely kind of counterintuitive because usually your primary key can't be null. Usually you expect to see an integer in your primary key and not a null value. So that's something you have to kind of be forewarned. This doesn't usually come up too often. But it can. The next thing is that you can have aggregate queries that also include columns that aren't part of your aggregation. So SQL Server doesn't let you do this at all. It will complain and give you errors if you try to run a query like this. So for example, let's say we have an employees table with a salary column, a first name, and a last name column. Well, typically I would say max salary. That would give me the maximum salary, and then I couldn't add any additional columns because it's taken all of the rows and kind of compressed it into one. Well, with SQLite, it will actually let you write queries like this. And as it turns out, they kind of mention here the first name and the last name they will end up returning are the employee with the maximum salary. That is really weird. Most flavors of SQLite do not let you do this. I know that SQL Server doesn't let you do this. I think that MySQL is the same way, where you can't do these things. This is kind of a weird exception to the rule. Okay. Another thing to be wary of, if you're working with text that's not in English, by default, SQL Server doesn't really function in a way that's locale dependent, locale appropriate. So the upper and the lower, which transform your text to uppercase or transform your text to lowercase, those only work correctly for ASCII characters. Okay, so what you're going to use instead, if you have, say, you need to do a case-insensitive compare, you're going to actually use a collation. There's a special collation built in. There's two special collations built into Android's version of SQLite. One of them is a kind of a local collation, and the other one is a Unicode collation. And you can use those for doing proper case-insensitive compares. Okay. Another little gotcha is that in SQL, typically all of your string literals, and SQL Server is very particular about this, that they usually need to start with a single quote and end with a single quote. So typically per the SQL standard, if it starts and ends with a single quote, then it's a literal value, but if it starts and ends with a double quote, then that is a like a name of a column or a name of a table. It's some sort of identifier name. So the way this works in SQL Server, if I remember right, they actually use square brackets for their identifiers. So you used a square bracket to define the start and end of a column or a table if you wanted to, say, have spaces in that name. Here, on the other hand, you'll use double quotes if you need to have spaces in a column name or a database name. Ideally, you don't want to do that. It's usually better to just avoid having spaces or special characters other than underscores and dashes in your identifiers. But that's the way that works. And just a reminder on that note, basically all flavors of SQL are case insensitive. So you can do camel casing in theory with SQL, but you really shouldn't, because it doesn't really respect that camel casing, if I put it that way. So if you have a name that is integer all uppercase, and then you have another one that is integer all lowercase, we'll treat those as the same. Or more exactly, maybe you named your column name all uppercase, and then you're trying to deal with the column as name all lowercase. It will actually treat those in a case insensitive manner, where it will treat those as the same thing regardless of the case. I think it's probably best if we take a quick break here. So let's take a quick 15-minute break and come back at 2 o'clock. Okay, so let's get back to it. So we're kind of going through some of the quirks that exist with the SQLite database and how it's a little bit different from maybe other SQL databases. So we just were talking about the fact that, well, you can use double quotes or single quotes for your literals, but also if you need to have kind of delimiters around your column names or your table names, you're going to use strictly double quotes for that. Okay. Another thing that's kind of a gotcha, SQL Server, for instance, is very strict about not letting you have or trying to prevent you from having keywords as column names. SQLite generally will let you use keywords as column names. You really shouldn't. You should do your best to avoid having a keyword as your column name, but the reason that exists is for kind of cross compatibility. So one of the things that often happens with SQLite databases is oftentimes people try to bring their, say, SQL Server or their MySQL or their Oracle database schema over to their SQLite database and try to use the same exact schema. So words that might be might not be a keyword in one version of SQL might be a keyword in SQLite's version of SQL, or vice versa. So that's why it allows that. It's just trying to be kind of friendly there in the sense of that. The other thing that happens is, say, over time there's been a few different versions of SQLite and the keywords have changed over time. Nowadays we've been at SQLite 3 for a very long time, and I don't see us really getting a new version of SQLite. I think that's very unlikely. If we did, it would have to be bundled into Android as far as that's concerned, because the SQL is built into Android. We don't actually kind of include that library ourselves per se. So that's one thing to be wary of. There is some kind of things, overall there are some things that you can do in SQLite which syntactically would look like you probably shouldn't be able to do that, you probably shouldn't do that, but it will let you do it. So that's the kind of thing to be wary of with SQL, is it's not very strict about hardly anything. So it'll kind of let you do whatever you want, whereas most relational databases are very, very strict about what you can do. Okay. Another thing to be forewarned, we usually use auto increment columns as our primary keys. You can use GUIDs or UUIDs as the primary keys in SQLite tables, but typically we're going to use an auto increment column. The way that works, I don't know the kind of nuances of all that, but there are some kind of discrepancies between how those columns are incremented, especially when it deals with, say, you delete rows or, say, truncate the table. The way that the next ID works and the way it deals with gaps is going to be a little bit different than how MySQL deals with gaps. Same thing with SQL Server. SQL Server's got different rules on the identity column. So those are all things to keep in mind. I've linked that here in the slides, but if you look on Perusal, let me bring that up on Perusal. This is also one of the documents that I've asked you to read there. So if you're looking on Perusal, this document that we're looking at is the SQLite 01. and there. So that's this on Perusal, if you want to come back and look at it. The next thing I want to look at is a little bit about the data types. I've also linked that same item here. So if I go to SQLite 02 data types, let's look at this. Yeah, size it down. So this is going to talk a little bit about how data types work in SQLite, which is different. They don't work. It's another kind of quirk with how SQLite works, and this is definitely something that you'll need to pay attention to even as we're using rooms. Okay, so with SQLite, there's this long article about data types, and it does go over how everything works. But there's a lot of details in here, so I want to kind of summarize it and make it more, kind of give you the best practice, the summary of what's here. So with SQLite, there's a lot of kind of terminology when it comes to, and a lot of nuance to how the data types work and how data is actually stored. So in SQLite, things are broken down into storage classes first. So this is the idea of storage class. Anytime you save a value in SQLite, it's going to be saved in one of these storage classes. So first option is, well, it could be stored as null. It could be a null value. Okay. Second option is it could be stored as an integer. Okay, so the integer would be like 1, 2, 3, 4, 5, 6, etc. And they can be in different byte sizes. You don't actually get to specify how big the storage is. So if you say big int versus small int versus tiny int, there's actually no difference. You just tell it to store it as an integer, and it figures out what size the actual data type is. So it's going to make that up on its own. So it could be anywhere from a 1 byte data type, 1 byte integer, all the way up to an 8 byte integer. It'll make that up. The next storage class is real. So real stores things like floating point numbers, so floats or doubles. It stores those always, you can see here, as an 8 byte. IEEE number. So what that means is there's 8 bits in a byte, so that's 64-bit, which means that any float or double that you store is always going to be stored as a double. Whether you specify the column as float, double, or real, it's always stored as a double in the actual file. In the actual database, it will be stored as a double. The next grouping that it can store or data as is as text. Okay, now that's important. There's a text grouping. There's not a separate like varchar, car, nvarchar, ncar, text, and text. There's only one text data type. Okay, so there are no limits to how short or how long your text can be. Okay. In SQLite, I can't say, okay, I want the zip code stored exactly as 5 characters. So normally in SQL Server, I would call that a car 5. If I specify a car 5 in SQLite, it will actually store it as a text data type, and that means that it can be longer than 5 or shorter than 5. So we don't really use the varchar or the car types when we're working with SQLite because they don't really exist. And they'll be stored in whatever encoding it decides to use. So it might decide to store it as UTF-8, which would be good for English language, or it might decide to store it as some version of UTF-16, which would make more sense for, say, Chinese or Japanese or some of the other non-Western, non-European languages. Okay. The final type that it can be stored as is a blob. Okay, so blob is just a series of bytes. When you read it in from the database, it'll come in. When you read it or write it out, it'll come in as a byte array. That's how that's stored. So if you need to store, say, image data or encrypted data, whether it be passwords or things like that, hashes, that's how it's going to be stored as a blob. That's a data. That's a byte array, basically. So what this means in practice with those storage classes concerned is it really means that SQLite only has 4 data types, and you should treat it as this. It really only has 4 real data types. So integer, real, text, blob. When you're defining your schema, you shouldn't have anything other than those 4 data types. There's a lot more nuance about other thing. You can specify the data type as many other things, and it will have some interesting behavior and try to figure out what to do with those other data types. And that's mainly, again, kind of a flexibility thing, trying to maintain some sort of compatibility with other SQL systems, because you want to say, okay, I'm going to take my schema from my website, use it on my app. That may not be the best pathway forward. So these are when you're creating your schemas, it should only be one. All your data types should be one of those 4. Yeah. So if I was going to store image data, I would store it as a blob. Any sort of text I want to store, I'm going to store it as a text. Any sort of floating point number, I'm going to store as a real, and any sort of integer or Boolean. Integers or booleans I'm going to store as an integer. Okay. Date times. Typically, I would store a date time as a text value. Okay. Any timestamps I have, typically I'm going to store that as a text value. You can technically store them as an integer value or a real value and work with it from there, but I would strongly recommend storing your dates and times as text. Okay. Now, with the way things work, there's the 4 underlying types that it's going to be stored as. You can actually specify a lot of different data types in SQLite. It will actually let you specify anything you want for a data type, and then it'll guess what you mean. So there's some rules in that article that I linked about how it does that guessing. There's a lot of nuance to how that works. But what it means in practice, if I say, for instance, integer, int, tiny int, small int, medium int, big int, if I say any of those data types, it's actually going to store it as an integer. It's actually going to treat it as an integer type. So any of these you can really just translate and say that's the integer data type. Okay, because there's really no difference between these types and the integer type. If you specify the data type as real, float, or double, again, they're basically just an alias for the real type. So if you would specify it in one of those types, just store it as a real. With character data, so if you specify car, ncar, varchar, nvarchar, text, ntext, any of these are treated as text. They're treated as the text type. So they're treated as an arbitrary size string, basically. So there's no minimum length, where car usually has a minimum length. You can say like car 5, and it has to be exactly 5. But there's also no upper length. So I might say varchar 20. Normally in SQL, that would mean that I can't have more than 20 characters in that varchar column. Well, it's actually stored as a text column, which is arbitrarily sized. So if you say varchar 20, it's not going to prevent you from having more than 20 characters. So if you're defining the schema again, you really just want to define it with integer, real, text, and then blob. And then blob would be just the one you use for images and encrypted passwords and things like that. Okay. Important thing to note on this chart. There is no Boolean in the Boolean or data type or date time types. We kind of mentioned that in the quirks bit earlier here, but just rehashing that. there is no Boolean in datetime type. If you try to specify your column as Boolean, it's going to do something very interesting. It's going to use something, it's going to fall back to something called numeric. And numeric can be, it's going to fall back to something called the numeric affinity. And the numeric can either be, well, sometimes it's text, sometimes it's stored as text, sometimes it's stored as real, sometimes it's stored as an integer. So you have to be very careful with that numeric type. So if it doesn't recognize the type, it's going to fall back and store it as numeric. So if you specify the type as bool or boolean, it's going to decide that the affinity of that column is numeric, which means that sometimes it's going to store your boolean as the string true or the string false, and sometimes it's going to store it as the number 0 and the number 1. It's really not what you want. We had some issues with that where when I was doing this professionally, where we ended up having some Boolean columns in there, and it turned out that, well, sometimes when we wrote them out to the database, SQLite would write them out as 0 and 1, and sometimes it would write them out as true or false. Same thing way when we read them in. Sometimes it would read them in as the text true, sometimes it would read them in the number 1. So really, you want to make sure that you use the integer type for Booleans, because otherwise you're going to have to deal with the case that sometimes your Boolean was stored as a number and sometimes it was stored as text, and you really don't want to deal with that. So you can read more about this if you go to the SQLite website. A lot of the articles from the SQLite website I've gone and put on Perusal because they're a good read to kind of get an understanding of what's going on there. You can also read let's see where this takes us. So a full description of the query language. There we go. That's part of their official SQLite documentation. And I've pulled down a few parts of that, so namely the select statement. This I've thrown up on Perusal. You can also just look at it on the website. And then there's some documentation if you look in the Java doc about the SQLite class and the cursor class. So those are all places you can look for more information. Okay. So that's the end of the slides. What I want to do next is get us kind of started up with maybe an example to kind of play around with this today, because we're just touching on the theory, the kind of background of the SQLite. There isn't really a code. There's no code lab built for 10.0. They haven't provided one, so the next lab is for 10.1. But I think it's worth us probably doing at least a code example with 10.0. So I'm going to do, I know we just took a break, but I think let's take a 20-minute break. I'm going to shut this stream down, and then we'll start a new stream in 20 minutes with going through a code example of SQLite, of how to use this with Android. Before I do, does anybody have any questions? Top 5 Pokemon of all time. Well, obviously you've got to put Pikachu up there, and Charizard, and my pal Bulbasaur. I don't know. That's 3. I guess Squirtle probably in there, and I don't know who I'd maybe pick for the fifth. Anyway, I'm going to shut this down. We'll see you I'll see you back at 2:40, and we'll start the code example.